let's have a look at software construction and the automation that's gone into that. In this particular topic, we'll have a look at the languages, libraries, frameworks and components. So not so much the tools of how you develop software or tools that help there, but the particular parts of things that go in to make up the system. Now, I've been particularly impressed with the general development of languages. Now, part of the reason for this is that I started out with assembler language, which is very, very powerful, but very easy to make a lot of mistakes in assembler. And there have been some notable errors, and some of them I caused some, and I had to debug some. But believe me, you didn't write a particularly large program because it became very, very difficult to follow. So high-level languages, what were called third-generation languages, these were things like COBOL. Fortran was there as well, Fortran, one of the earlier languages. These tended to be less flexible. They constrained you in a certain way to some things that you could do easily, and some things, obviously some things became much more difficult. But in doing so, they allowed much more to be done much more quickly with much less error. Now that was fine, and there's been a progression of languages over time. The COBOLs of the world, COBOL and ALGOL and PL1, I think, were some of the languages that were fairly popular earlier in the piece, and they were followed by the rise of C. I think was invented later in the late 60s. Now C was very popular because it's the techies language. You can get down and do all sorts of things in C, but you can make a whole lot of errors in C. Now then came what were then called the fourth generation languages. These tended to be very almost like report writers or something of that nature. They enabled simple programs to be written very quickly, but they weren't suited to, you wouldn't write an operating system in a fourth generation language. You couldn't. But you could write programs very quickly and quite accurately. That was great. Now these were followed when the bitmap graphic screens came out, and the default interface was largely a PC and something reasonably intelligent. And also, I think when the internet arrived, suddenly we had a need to deal with much more than just the data and with a very crude screen. So that saw the rise of a new collection of languages, particularly and notably Java, as well as the C# and C++, and some of the other languages such as Python and PHP that came out. While these are reasonably powerful languages in their own right, they do have structures and constraints in them that help avoid a lot of errors, which is great. So that, I think, was a major advance when the language itself prevents you from making some of the errors. So better languages tend to be less error prone. One of the other inventions that came along was the invention of libraries, that you could buy a library like a math library or a library of methods to plug in for structural analysis or something like that. Now these enabled any developer to access to a whole lot of things that would otherwise have taken a lot of programming to do and a lot of time and trouble to debug. So if you could buy things that were already pre-built and worked using someone else's expertise, this, I think, is a great thing. It avoids a whole lot of bugs around the place. So libraries became popular and were sold. A lot of the C libraries were there. These have been followed more recently by frameworks. Now frameworks are an abstraction of a problem into some recurring securing kind of thing. And this enables people to focus on the particular problem they're trying to code, rather than the implementation of all of the details, like the access to the screens and the handling management of the screen and the buttons and the behaviors. If they can all be put into the framework, well, great, because that means that there's even less that you have to program and get wrong and debug and play about with. So frameworks have come up and been quite popular. They seem to be distilling down to a number of fairly popular frameworks, and as the way of these things, you'll probably get a few dominant frameworks and then a whole lot of less dominant frameworks. So the ones that seem to be quite popular, Ruby on Rails is one, Cake PHP is one, Django is one, and Hadoop is another. Now, there is a difference between libraries and frameworks. A framework generally takes control. With a library, you've got control and you call the library when you want. Whereas with a framework tends to take the control and control the execution of whatever it is. Although a framework can be extended, it usually can't of itself be modified. And aside from which, why would you? I mean, you've got this huge big thing there that you bought because they've got expertise. Why would you then go and mess around with it? Now, presumably some people will try, because people always do. Now, the components although it's been seen as a fairly big thing, components don't seem to have become as popular as they might have been. But some of the more obvious components are things like database management systems. Very few people these days write their own. I mean, you just buy one and you put it in. Similarly, telecommunication, internet communication protocols, you tend to buy those and just use them, and along with a whole lot of the interface parts to it all. Again, if you can buy one that works and use it, it's you won't make quite so many mistakes. And this, I think, is a great contribution to quality. The best bugs are the ones that you don't write and don't incur. So buying something that already works and using it, I think, is a great idea. So in summary then, the more powerful languages have arisen, possibly with some reduced flexibility, but we don't seem to have suffered too much. Some of that reduced flexibility has translated into having just simply bigger programs, or programs that are a bit slower. But these have been overcome by the significant rise in the capacity of computers. Even so-called very small computers these days are quite powerful compared to what they were. So the more powerful languages tend to take care of more of the details and essentially prevent errors by not allowing them in the first place. So we're tending to get less errors of, say, syntax, less errors of minor misjudgments. And we still get other errors, but we get less of those.